Okay, I'm probably going to bring these. Little toys in, and I apologize to one of the students who my bookshelf back here drives them absolutely out of their gourd. Sorry, I keep forgetting to straighten. So this is going to work. Here's what I've got. I got a battery. Okay, got a nice little 1.5 volt direct current. It'll be a DC battery. Nice piece of wire. Okay, nice piece of wire. And it's a good conducting wire. It's kind of expensive little piece of wire here. And then I've got a nail with a magnet on the bottom of it. Magnetic field's going up. I'm going to put a current sideways here on the thing. That's going to create a torque that goes in. It's going to spin this sucker. Watch. Watch. Look at that. Spinning like crazy. There it goes. Spinning, spinning, spinning. I don't know if you can see that or not. You see it spinning? It's spinning. It's really got a lot of torque. It's really spinning. That worked really well. A lot of times that, ooh, it's hot. A lot of times that thing doesn't work. Okay? But here was something that I kept meaning to bring in for a long time. You don't think we have an electric current going through our body? Grab this end of this electrode. Grab this end. Whoa! A lot of quantum mechanics at work here too. I'm a conductor. I conduct. All I need is a power source to line those things up and move them through. All right. I'll bring this stuff in on Friday. Friday's always a good day for demo day, and these are easy to bring. All right. Okay, so now let me knock this off. Okay, here's a slinky. It works great as a coil. Okay, to show you a coil. All right, so here's what happens. Here's what happens. All right, so I've got a coil of wire here. Got a coil of wire, and it's got probably 50 or 60 loops. Here's the deal. If I've got, and I'm going to show you the thumb rule as Tyler learned it. Okay, I call it right hand rule number 2. Okay, basically I'm going to grab this thing. Okay, and as the current is going through here, let's say the current is going through this coil in a clockwise direction like this. Then I put my thumb in the direction. I'm sorry, my thumb's so nasty. If my hands got cracked and everything is running in the morning. Put my thumb around here, and then my finger goes down through here, and that gives me the direction of the magnetic field, which is coming with my thumb. Okay, well, I mean with my finger. This is the current wrapped around. You'll see it much better when I show you on Friday. Okay, so a coil going around in a circle, clockwise direction like this, creates a magnetic field that actually goes down. Okay, and you could do, and here's what I want you to do. You're going to make your own. This is part of the cheat sheet that you're going to bring. Here's the deal. You move the current, here's my current, here's my B field, and here's my B field popping out the other end. And it works every time. Okay, so if my current is going on this thing, if my current is going this way, B field's going in the middle. My current's going the other way, the B field's coming at me. Okay? That's all there is to it. If I have a straight wire, with a current, B field's going in over here. In other words, it's curling around. The thumb rule says I grab it like this. I just grab the wire, grab the pencil, and which way is my fingers curling around. Okay? But if I put my thumb in the direction of the current, just like you did with the velocity, okay, that curls around. So if the current's going this way, thumb in the direction of the magnetic field, it's much easier doing it this way. the current's going that way, then I've got a magnetic field going in over here and popping out over here. It's popping out. Okay? That's all there is to it. And these two fields, equal straight wire, the magnetic field is equal to mu naught I times the current over 2 pi r. Why is it for a straight wire? Because why is it 2 pi r for a straight wire? Ampere's law. It's going in a circle. If the wire's going in a circle, then the magnetic field is straight. The geometry of the magnetic field makes it go straight. So for a loop of wire, B is equal to N, the number of loop times mu naught I, over 2r. No pi. Loop gets no pi. All right. The loop gets no pi. All right. There you go, where N is the number of turns. Then and that's it. That's the big idea. That's the big idea to the rest of this chapter. So here's probably the cheat sheet you're going to bring for the next exam. Okay, I know this magnetism stuff seems like, holy smokes, this stuff is impossible. No, it's not. You'll be fine. Trust me, I'm a doctor. All right, what do I do with the rest of your problems? Because I had all kinds of I had the problem sheets out here ready to go. Here they are. So let's take a look at this. 2 rigid rods. Oh, this is fun. 2 rigid rods. I don't want to think about that anymore. No, but anyway, 2 rigid rods are oriented parallel to each other and to the ground. Okay, so here's the ground down here. I've got one rod like this. The rods carry the same current in the same direction. I going this way. The length of each rod is 0.85 centimeters. I going this way. Okay, so here's the ground. Now, what are these rods going to want? And they got current going like this. All right. And they have certain mass, and one rod is held in place above the ground. Okay, so I'm going to hold this one. This one is cemented to the ground. Okay, it's held in place to the ground. All right. So they're going in the same direction. All right. Now here's what's going on. Determine the current in the rods. What? What are you talking about? And they're this distance apart. They're a certain distance apart. Okay. Well, here's what happens. Here's what happens. We'll just get this started, and this will be the last slide. All right. So I've got I going this way, right? The current is going this way. So this guy's making a B field. He's making a B field. That's going to come here. And the B field made by top wire, is equal to, it's a straight wire, so it's mu naught I times 2 pi d, that distance d. Okay? But it's striking this wire right here. Boom. And it's going into the page. The B field is going into the page. Got a current going this way. Current going like this. B field going like this. Which way is the force going? You got it. It's going up. It's another one of those things where we're opposing gravity. So it's got mg pulling it down. And it's got ILB pulling it up. So mg equals ILB, where B is equal to mu naught I of the wire that's held divided by 2 pi over d. Cool problem. And then we'll look at this last one in class. Out here.